students, today we will discuss the topic testing for serializability. Now, when multiple transactions are being executed by the operating system in a multi-programming environment, there are possibilities that instructions of one transaction are interleaved with some other transactions. So, serializability identifies those executions of transactions guaranteed to ensure consistency. Means through serializability we can achieve consistency. So, how can we test for serializability? Now, the test is as follows. Let us assume that there is a schedule S. So we construct its directed graph or precedence graph. This graph G is a pair of vertices and edges V and E. V is a set of vertices and E is a set of edges. So, set of vertices consists of all the transactions participating in the schedule. So, suppose if there are 3 transactions in a schedule, so there will be 3 vertices. Now, set of edges consists of all the edges Ti to Tj for which one of the 3 conditions hold. Now, there will be an edge from transaction Ti to Tj if these conditions hold. First condition is Ti executes write A before Tj executes read A. Means if Ti transaction execute write A operation before Tj executes its read A operation, then there will be an edge from Ti to Tj. Second condition is if Ti executes read A before Tj executes write A. So if Ti transaction execute read A operation first before Tj executes its write A, then also there will be an edge from Ti to Tj. And last condition is if Ti executes write A operation before Tj executes its write A operation, then also there will be an edge from Ti to Tj. This means that the transaction who is executing the operation first, the arc will be edge will start from that transaction only. So we will keep this in mind when we will draw the precedence graph. Now suppose there is a schedule S in which there are 2 transactions. So we will have 2 vertices in the precedence graph T1 and T2. And as you can see, transaction T1 is executing its operations first. After that, T2 will start. So the precedence graph will be like this. The edge will be from T1 to T2. Why? Because there is one edge and 2 vertices T1 and T2, and arrow indicates that all instructions of T1 are executed before the execution of first instruction of T2. You have seen that T1 is executing first, and after that T2 will start. So the edge will be from T1 to T2. Now let us take another example. If we have a schedule like this, now you can see that there are 2 transactions T1 and T2, so 2 vertices will be there in precedence graph, but the operations of the 2 transactions are interleaved. As you can see, first T1 is executing, then in between T2 is executing, then again T1 and then T2. So precedence graph will be like this. The arrow will be in both the directions. This is because firstly T1 is executed, then T2, then again T1 and then T2. Now here the graph has cycle. As you can see the precedence graph, this graph has a cycle. So If the precedence graph for S has a cycle, then the schedule S is not conflict serializable. But if the graph contains no cycles, then the schedule S is conflict serializable. So you have to keep this in mind. If the precedence graph contains no cycles, then the schedule is conflict serializable. So that's how we can test for serializability. Thank you.